Our world has never been compartmentalised. If we want to understand past environments, we need to look at the traces they've left behind. One way to do this is through paleoparasitology, the study of ancient parasites preserved in things like coprolites, mummies, and sediments. Since many parasites have specific environmental needs, their presence or absence in ancient remains can tell us a lot about past climates and ecological shifts. Take complex life cycle parasites, or CLPs, as an example. These are parasites that rely on multiple hosts and the environment to complete their life cycle. So, they tend to thrive in warm, wet, tropical conditions that mirror their host's internal body. This means that CLPs are far more common during warm, wet periods and less so in colder, drier, or icy conditions.
Shiver me timbers.
Because CLPs need the right temperature, humidity, and host conditions to survive, studying their remains, like eggs found in coprolites or fossilized tissue, can give us a unique window into our evolving world. When combined with other paleo-environmental data, like pollen spores or ice core records, paleoparasitology can help paint a fuller picture of how ecosystems have changed over time. Archaeologists digging through old Norse latrines in Greenland, yes, that is ancient poop, found whipworm eggs, showing that Viking settlers once lived in a mild and humid climate. But as the Little Ice Age hit in the late 13th century, things got colder and drier, conditions that likely made life tougher and contributed to the settlement's decline. Schistosomiasis, a disease caused by parasitic flatworms, has been around in Egypt for thousands of years. The oldest evidence of Schistosoma hematobium infection comes from mummies that are over 5,000 years old. Since these parasites thrive in standing water, their presence suggests that Egyptians were frequently exposed to the Nile's floodplains, lining up with historical records of seasonal flooding. In the Andean region, scientists studying ancient human waste, yes, more poop, found helminth eggs, giving clues about past climate changes. In dry coastal areas, the presence of these parasites and their eggs suggests that occasional bursts of humidity, probably thanks to El Niño events, briefly turned arid landscapes into wetter environments, changing up the settlement patterns. So, parasites are nothing new. In fact, they've been around for hundreds of millions of years. The oldest evidence of parasitism dates back to the Paleozoic era, roughly 515 million years ago. Fossilized brachiopods from the Cambrian period even show tube-dwelling parasites attached to their shells. This suggests that parasitism has been shaping ecosystems and host evolution since the earliest days of complex animal life. The presence of these ancient parasites also hints at periodic warm, shallow marine environments that allowed for intricate relationships to develop. Of course, like all things, paleoparasitology has its limitations. Many parasites don't fossilize well because they have soft bodies, leaving gaps in the fossil record. Plus, parasite abundance is influenced by more than just climate. Host migrations, ecological shifts, and competition all play a role. But when combined with other paleo-environmental data, these fields provide valuable insights into past climates, helping us refine climate models and understand long-term environmental trends. Ultimately, studying ancient parasites isn't just about the past. It helps us contextualize the present and anticipate the future. Climate change will inevitably influence parasite abundance and distribution, just as it has for millions of years. The more we learn about these ancient relationships, the better we can understand and respond to challenges ahead. Or that's the hope. Our world has never been compartmentalised, and it never will be. To truly understand it and care for it, we need to embrace an interconnected, holistic approach. Paleoparasitology is just one piece of the puzzle, but when integrated with other scientific disciplines, it can help unlock a richer understanding of both our past and our future. Stu, the imaginary parasite, thanks you for listening.
See you later. Bye-bye.